So, the dear colleagues, respected scientists and intellectuals, a very good afternoon, very warm good afternoon. I am Dr. Mumtaz Khan, and the current presentation is related to the emerging technologies in the environmental sciences, which is going to be a paradigm shift for the sustainable solutions. So, my name is Dr. Mumtaz Khan, and I am a nuclear chemical scientist and also working in the environment because of my profession, my field is related to the more interdisciplinary work. So without delaying, I will present the history of the environment and the dimensions of the environmental challenge and what are the technologies that are used to monitor and mitigate the environmental challenge and the conclusion. So this challenge is posed because of the industrial revolution. Before industrial revolution, there was no environmental challenge and the global progress was in harmony with the environment. You see, the Muslims have a green flag, a green color as a symbolic that was called a crescent. A Muslim also represented as a fertile crescent and green color. These were the symbols. While we know that the Prophet movement, their flag was a black color. So why this turn change? So during the Abbasid Caliphate and here in Pakistan and India, we had a green agricultural revolution during the Delhi Sultanate and 13th century and onward. And during that time, much more emphasis was on the green technologies that were in harmony with the globe. The Persian well that was run by the animals and all the things. You see, I see my grandparents. They throw the product. They don't collect the garbage. They throw to the environment. So at that time, I think they were not civilized and throw the garbage into the environment. But later on, we realized that during their time and their forefather time, there was no things like the garbage and whatever was the garbage that was the green. They returned it to the environment. The disharmony arises during the industrial revolution when the mass production started and the local water pollution started in the Western Europe. And the London smog is the famous because there was no smog in Pakistan or in the eastern side because the pollution was much more localized because the industrial activity was in the west. And you see, one house is usually when we build a small house takes 50, it generates 50 to 80 kilogram of carbon dioxide per square meter. And 1 kilogram is carbon dioxide is produced, estimated, maybe wrong, but there is the carbon dioxide produced. A certain quantity is produced from 1 kilogram of the cement. So the industrial revolution and that is fueled by the capitalistic economic system. There is no doubt in this now that the following in the next slide the data will show it. So this has led to the environmental problem and the subject environment as a study is also emerged in the 20th century because before that there was no need, so there was no subject and there was no discipline and there were no professors and people because their lifestyle and habits were designed in the religious way to protect the environment. For example, when the people say that don't excessively use water for the wuzu, every drop of water will be judged, will be asked on the day hereafter. So that's the religious way to protect the environment and inbuilt mechanism in the ideology. But the post-industrial era, the excessive use become natural and become fashioned and become civilization, the symbol of civilization, and the talk on the environmental, the privatization of everything is started. So the first phase started around 70s, 50s, and then the 1800 and 19th century, still the pollution was local where the industries were, and the eastern side of the globe was much more relatively clean. Even until my childhood in 2000, The water in the Punjab we drink with the tap water. In the Western era, the post-war era is supposed to be urbanization shift and the acceleration of the global population and lifestyle change that started the construction of the fossil fuel power plants, and then the started the fertilizers used in the agriculture. And then this accelerated the fertilizer use and the power plant and the excessive industry without regulation. They were throwing the carbon dioxide into the environment and the pollution into the water without any challenge. Okay, and then the modern era that is started after 1950s. So you see the here the carbon dioxide is rising rapidly after the 1950, because after the third revolution there was a lot of fossil fuel power plants and the excessive use of fertilizers. These are the prime contributor of the global warming and the climate change and environmental crisis. Until 1950, the problem was not global because the progress was in just Western Europe and in the Japan that are both extreme end of the plan. Because and the wealth created by these revolutions, industrial revolution, they paved the way for the colonialization and the nation started to rising, and the China and the Africa, even in Hindustan, Pakistan. So they realized that capitalism is a worth to get money, to earn the power. So everyone started building plants. But after the 1950, you see it is the exponential, not the global phenomena. The environmental challenge is not just to the Western Europe. So now it's a global after 1950, and you see now it's the rapid, it's much more exponential, and even maybe it will be much more exponential in the next. But as for 23, now it's 420 ppm in the environment. And now it's not just because of the climate change. There is the linked problem is the deforestation to build more homes, to build for more agriculture, the pesticide agriculture, the fertilizer agriculture. And that has led to the acidification of the ocean and the acidification of the rain. And that slight change in the pH will have a greater loss in the biodiversity. So that's why we need a global awareness and the global response, because we shared it, we have it. And in 2014, there was a survey conducted by the Public Health Engineering Department. I was consultant in that project. And later on, I published this work. You see, the Punjab was half Punjab. The eastern side is more red or going to be red. And the left and the western side is little green and that time, but now it's more yellow and going to red. That is because of the less use of fertilizer and less use of industrial activity in the western Punjab, but more in the eastern, southeastern Punjab along the GT road, along the road that is going to the Karachi, that is the Multan road. So the pollution is air, water, and soil pollution is actually is not only the one, it's a one side of the coin. The total picture is biodiversity loss and climate change because of the rising temperature and extreme weather conditions. Even in Russia, the extreme north, the glaciers are melting and the new rivers are being produced in the Russia. And this, our Indus River, that mighty Indus River, is going to be maybe too much flooding and too much dry season. There is the patterns are shifting. The new pattern are still are not clear. So there are four cycle which we know, that is nitrogen, carbon, hydrological cycle, phosphorus cycle. These four cycles that are essential for the life on the earth, not only for the humans, but also the ocean life. Because if too much acidification, because of the carbon dioxide or the phosphoric in as ionic form in the atmosphere, that will cause the more acidification. And the slight decrease in the pH of the ocean can kill much more species of the ocean. And ocean is much more diverse in creature than the surface of the earth. And that is linked with the fertilizer use, with the pesticide use, with the power plant emitting much water into the environment as a vapor, then the sun release evaporates for the condensation of the rain. So these cycles are being speed up. The things which were in the precipitated and the solidified or the liquid now becoming in the physical liquid state and the vapor state and the ionic form, and they are releasing into the environment because of the heavy traffic that release the carbon dioxide, acidification, cement industry, whole of our industry, out from homes to construction to the roads, everything, and the electricity we consume too much, and from the fossil fuel, they generate water vapors and the carbon dioxide. And then we use fertilizer, it creates the smoke through nitrous oxide production, and then the acid rain, and the water pollution. So these are the challenges. And now the technologies which, this is the empirical evidence, this is the observation over the lifetime. But what is the quantitative data? Where is the quantitative data? It comes through the chemical analysis, like we did this during the Punjab groundwater survey. This is the samples collected and then chemically tested, and the data was plotted. But now, and this project was 4 years, many resources, but now the environmental data collection has become more smart. The invention of the pH sensor, the temperature sensors, and sound sensor, and we can monitor the habitat through motion sensors, and the soil pH and soil moisture sensors. So all the data, real-time data, can be collected on a cloud and then can be used to analyze with the help of AI, and we can train the algorithm, machine learning, to predict the future things. But the sensor and IoT is again a localized thing, but we are using, and we will use, the satellite for the remote sensing at the bigger scale and the global scale, for the monitoring of the glaciers, and as well as the ocean, and as well as the monitoring of the deforestation. So these things are really important for the monitoring of the environment before making a real-time quantitative decision. And the blockchain technology will help to organize the resources along the way. So the nature-based solutions are not only there, but they are serving since centuries, since millennia. The phytoremediation, the plants that used to extract the pollutant, and the fungi that is used to extract and decompose the pollutants, and the birds that are part of the ecosystem. And these are also not only the monitor, they not only sustain the environment, but they also monitor the environment. And then the wetlands. And the nature-based solution, the fungi is important because it decomposes the the bad pollutants, not only the matter, inorganic, rather organic. It's much more focused to the organic. And these are part of the ecosystem, the part of the jungles, the life. And then the nature-based solution, you see the wetlands, you see in the Punjab, when the Punjab villages were designed in the 1850s, 1880s, 1890s, every village has a pond. At that time, it was more clean, but now it's not, because of the untreated toilet waste is being discharged into the ponds. So those ponds were designed at that time to protect the environment of the village in the Punjab. And these are the wetland actually. And wetlands have plants, not only the surface plants, but inside the water there are plants. But because of the excessive pollutions, the sunlight is being blocked to reach to the surface of the wetlands, and then the plants are dying. And thus these wetlands, which are necessary for as a natural treatment plants that will remain in the future. And then comes the phytoremediation was used in the Fukushima power plant to treat the radioactivity, to extract the radioactivity from the soil, to decontaminate the land. And birds now, there is dedicated research being done on the birds in the world, that the birds specific to pest control instead of the pesticide. There are birds that love certain worms, certain small insects. So instead of the pesticide, these will be used to treat the environment, because the birds are essential. These are not only essential for the pollination and the seed dispersal, these are also part of the global environmental system. Apart from these nature solutions, there are some advancements in the genomics and biotechnology. So the research is being done to convert the genetic engineering for the new species that are more sustainable in the environment, with the changing environment, and resistant. And the biotechnology for the carbon capture and sequestration. And there is research for the enhanced biodiversity conservation efforts and multi-layer farming. To assess the loss, we need LCA, LCC tools for the carbon dioxide and the greenhouse gas emission calculations. So these are part of this modern technologies. And photocatalytic reactors and the gamma radiation reactors that are used for the GHG treatment. And apart from these technologies and solution, we need a circular economy. Waste from one industry and fuel for the other is essential. For the nuclear heat waste can be used for the district heating, for the treatment of water, okay, and for the production of carbon or hydrogen. And then hydrogen can be used for our as a fuel and electrolysis, and even can be used for the fuel for the fusion. So the conventional technologies for electrocoagulation and chemical coagulation will be replaced with this phytoremediation and the other solutions. So traditional wisdom is much more important. Every generation experience are much more important than the small scale scientific money motivated scientific discourse. Scientific discourse is much more important, but money motivated or money pushed scientific discourse is not a right choice. So we need a simple solutions and simplicity in lifestyle, not on a personal scale, but at the state level, at the global level, at the United Nations level. That the United Nations is doing efforts to promote this thing, but speed is much less and the powerful individuals are more important. So the no fertilizer use will save the planet, because the fertilizer is proven that they have contaminated the groundwater, causing smoke. And then the natural cycle, that is the winter and the autumn and the spring. The autumn gives the leaves to the planet, to the soil, and that increases the organic matter in the soil and the phosphorus and other nutrients in the soil. Okay. So let the planet recharge itself. Please give a time. Reuse instead of consumable things, and the shared resources to decrease the carbon dioxide emission, and the deurbanization to give a particular place a chance to revive. Waste from one is food for the other. For example, in the traditional way, in the villages, the crops are harvested to feed the animals, and animal give a tongue to feed the soil. So this is cycle, and the milk is a byproduct. If we see from the nature perspective that we drink, okay, so it's food for us, and we when die we become a food for the organisms. So that's a cycle. Let the cycle work. Don't over exploit to get more money. So that's my wisdom or my view. So the social economic benefits of emerging technologies will be much more, because more jobs will created in the IoT and the Internet things and sensor technology and the phytoremediation and the blockchain and the genetic engineering. Okay. So there will be more jobs and cost-effective solutions. We need a more multi-layer farming farmers. Okay, we need a more people in the this balance industry, to create a balance industry in the agriculture and the economy. So the path forward is understand the challenge, and this will be done through real-time data analysis, real-time data monitoring. Okay, and the technologies will pave the way for integrating technologies and nature-based solutions is important, and the global cooperation. And not only simplicity, adaptation by the individual is not matters. It requires state intervention and state level policies, and then the education and the awareness will lead the way to long-term sustainability vision. So I am open for the collaboration and research, and the email, my email is there. So the conclusion remarks, I say we need a together social, we need a new social theory to save this planet. The technologies will provide a data to understand the problem, but the data driven decisions need a new theories for the economic development and the wealth sharing for this process for the new future. So we live on this planet, and we have to leave it livable for the future generations, and the environment technologies are important. Thank you very much, dear colleagues.